Hello and good evening. If your students had to pick which is easier on the SAT, the calculator or the no calculator section, what would they say? I know mine would say that the calculator section would be easier, just because they would have access to a calculator. And I'm not sure that's totally the case, but our panelists tonight, Jeff McCullough and Tom Reardon, they have a lot of experience with the SAT and they're definitely here to share all of their valuable insight. So my name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus and statistics near Pittsburgh, where I use TI technology to make those tough-to-teach, tough-to-learn concepts accessible to all my students tonight. And tonight we have Jeff and Tom, and these two guys just have a ton of experience, everything from long-time classroom teachers to working for Texas Instruments in product development to authoring books. So these two guys just have a lot to bring to the table tonight. So Jeff, I'm excited to have you with us tonight.
Thanks.
And Tom, same as you.
Yeah, I'm excited to be here with Jeff too.
And Jeff, I know you're going to be able to talk through some of the stuff we're going to do tonight.
Yeah, so we want to give you some interesting problems. I think these are, there's not that many problems, but man, there's some interesting ones there. And we're going to tackle some of those. They're free for you to use in your classroom. We written them so there's no copyright issues. We're going to go over technology uses, so to AT84 and TI-Nspire as we need to cover that. And then I love that if you just for attending, you have a chance at winning a drawing here at the end of the webinar. So
I know, Jeff, you like free stuff, and so that's right up your alley, right? Yeah, for everyone that is attending tonight, one lucky winner is going to receive a free TI graphing calculator of their choice. So hope you're the lucky winner. And then I think, Jeff, you're going to keep the ball rolling here and talk about some things that hopefully we can expect to be able to do at the end of the webinar tonight.
Yeah, and we want you to be able to, tonight we're going to explore the math that's on the SAT, quite a varied amount of different math stuff. We're going to use technology to do the math. And then I think one of Tom's favorite things, we're going to show you how the technology can help you understand the math as well. I think using the calculator and the technology.
If you missed it, Tom and Jeff did a ACT focused webinar just a few weeks ago in January. I can show later where you have access to that in case you missed it or you might want to see it again, but it's available on demand on our website. We're expecting a large crowd tonight, so your audio is automatically muted. Feel free to send any questions that you have for Jeff or Tom at any time. Use that Q&A window on the right side of your screen, and we're already using the chat window already to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. All right, Jeff, let me give you control, and you can share your screen and get things started.
Okay. Yeah, Wesley already made a comment, which is very true. He said that that on the no calculator section, you kind of want your calculator. I mean, it'd be nice to have. And the calculator section, sometimes you don't even need a calculator in some of the questions. But these are, again, really interesting questions. I want you to, I hope that you have a pen and pencil nearby so you could actually try to solve this problem. So when you see this problem right here, this problem number 13, we have a PDF we provided you. You can click the link for that if you didn't already get it. But I want you to try that problem and see what you're going to do. Just how would you approach that problem? I'll just give you just a few seconds to try that. And if you want to say what you would do in the chat window, that'd be great. And Tom, you could just kind of relay that to me and see what's happening there.
So synthetic division is popping up 4 times.
Nice.
Long division, synthetic division. So those are the suggestions.
Yeah, and Tom, I don't know if this ever happened to you. I saw this problem, and maybe it's just from all the work we've done with test prep. I saw this, and everything in my gut was like, I'm going to factor that guy. You know what I'm saying? I didn't even glance at the answers first. I was like, okay, I'm going to factor this. So I spent all this time factoring it. I was like 2x, x, It's got to be 1 and 2. I'm guessing maybe that minus plus. I think I did that right. And then I said, okay, doesn't he? I was kind of hopeful that something would cancel, and I just wasted like 30 seconds, you know? I don't know if you ever do that, but I think our students need to see that sometimes, even as math teachers, we don't always approach the problem the fastest or right way. Don't you feel that way, Tom?
Yep.
Yeah. And so I tried that first, and it didn't work. And then I glanced at the answers. I thought, oh, I bet division would be here. So you could either do long division or synthetic division. You know, put -2 in the box. This would be a quick way of doing it. -7, positive 14, 12. And so then right away, you can see that probably C is going to be our answer there. Just looking at the synthetic division. Now, our students, it doesn't say divide these two polynomials, and it's not obvious, at least when I saw the question, that, yeah, I was just trying to simplify it, that's probably what we should do. And so I like our students to have some backup plans. And so one of the backup plans, I remember Scott came up this originally, but if you plug in 0 or 1, so this is one of the strategies we talk about, plug in 0. So let's try that. Let's plug in 0 right now into the original problem and see what happens when we plug in 0. So I'm going to take 0 and plug it into this. Usually that's pretty easy to do into the original problem here. So this is -2 divided by 2, which is -1. So I'm hoping when I do this, plug in 0 for my answers, that maybe they'll be equal to -1. So let's see what happens. This would be, let's see, 0 plus 1 minus, if x is 0, that would be 4/2, which is 2. 1 minus 2 is also -1. So maybe that's going to work, but it doesn't guarantee it. Plugging in 0 doesn't tell you for sure that's going to be the right answer, but it should eliminate a few answers, hopefully. Let's see what happens. 2 times 0 is 0, minus 1, also -1. Oh, wow, this is not working great. So this is going to be 0 minus 7 plus 12/2. So -7 plus 6 is also -1. Hopefully one of these eliminates. This would be 0 minus 7 minus 16/2 or -8. That's definitely not the answer. So by plugging in 0, we've eliminated one answer. Again, what I like about this is it's a backup plan, something that could work if you're not sure what to do with a problem. It's just, okay, let's just plug in 0. Now let's plug in 1. So if I plug in 1 for x, or everywhere there's an x, I'm going to plug in a 1 there. So that would be 2 minus 3 minus 2 all over 3. So 2 minus 5 is -3/3, which is -1. Wow, weird. We get the same answer, plugging in 1. And now if we plug in, let's see if this maybe eliminates a few more answers. So this would be 1, which is 2 plus 1 minus 4/3. I'm not even going to bother to work that out. I can see there's a fraction there. It doesn't equal an integer. This would be 2 minus 1, which is 1. Now I know that one's got to work. And so that's just a method that it works really well in the no calculator section, but it even works on the calculator section. Tom, I don't know about you. I forget about that method sometimes of using that method. What do you think?
Sorry, I was watching the chat. I've got several things I got to talk to you about. So
Yeah.
sorry.
What do you got there?
So a couple people said to use the remainder theorem by substituting -2 into the numerator, and that will give you the remainder, kind of like using synthetic substitution.
Oh, wow.
Somebody else said graph the numerator and trace the -2. Okay, Julie said that, and I think it's Galit, Galit.
Wait, so graph the numerator. So if we graph the numerator, I had not thought of this method. No way I had 2x squared minus 3x minus 2. And then trace.
And trace to -2 because that's where, because we're dividing by x plus 2, trace to -2, and it should take
We
you to
got
12
-2, 12.
because of the remainder theorem.
And so we knew the remainder has to be 12,
Yeah.
right?
Yep.
Oh, wow. That's a really interesting move of just what a connection there she's made. That's really interesting. That I wouldn't have thought about that. Or look in the table, right? So on the
Yeah.
Nspire, you can hit Control T for a table and look up -2 and see 12 in the table.
Mm-hmm.
So great examples. I like students having a backup plan, and it's kind of amazing that that backup plan of plugin 0 or 1 works on a wide variety of problems I would never think to do that with, like this one.
Oh, hold up, Jeff, before we go on. Could you go
Sure.
back? There was one other way that you kind of told me about
Yeah.
was using the remainder in the numeric. Like if you substitute a number in the numerator and denominator for x and divide and
Okay.
use the remainder numeric, I think it'll come up with 12.
Okay. So say that again. I want to do a fraction.
So just go ahead. Let me think about that. Go ahead on to it. Let me go on to it.
Okay.
Go ahead.
Okay.
Go ahead. Go on.
I like that idea. Okay. So like this one, totally different kind of problem, but I actually think the method still may work. Now, plugging in 0, everything would be 0. You can take about 2 seconds and think that through because you're multiplying 0 times everything. But if you plug in 1, so if x equals 1, and in this case, y equals 1, I think that'd be pretty easy to plug in here. So this would be 4 plus 12 plus 16, which is what, 32? And doing this would be 7 times 4, which is 28. This would be 28 times 4, which is, wow, way too big, 116 or something like that. This would be 8 times 4, which is 32. I'm already thinking that's probably it. And this would be 19 times 4, which is 100 and something. And so that's kind of interesting that that strategy works in a lot of different situations. Plugging in 0, if that doesn't help, plug in 1 and kind of see how to go from there. How else could y'all solve this this problem here other than plugging in 0 or 1 as a strategy? What other ways do they have? Oh, I like the elimination idea. Someone mentioned eliminate A and B right away. There's only 2 terms there and there's 3 terms there. Common mistake our students make when they factor out a 4xy, they think this term kind of goes away.
Andrew says he teaches Fonzie, fraction 1, -0, and integer until only one of them works.
Fraction, what's that mean?
What number I guess that he plugs in? He plugs in a fraction, a 1, a negative, a 0, and an integer until only one of them works.
Huh. Oh, so he just plugs in random numbers come. I like 0 and 1 to start with just because they're easy to plug in usually as an option.
Okay, another person said use the answers to distribute.
Oh yeah, so just
Distribute the
distribute
answers
the
and then
answers.
see which goes
And that's
back.
usually an easier thing than factoring, right? So that's the idea of taking the answers and working with them. And that's actually an easier skill than factoring. I totally agree with that, to make it easier on your brain.
And that Gaelic, and I hope I'm pronouncing his name, he or her name correctly, but said you could eliminate A and B immediately without any work because there's only 2 terms
Right.
if you distribute.
Yeah. Okay. That's good. Again, we've got a wide variety of problems here. If you look at 24, I thought this was an interesting problem. The answer isn't maybe intuitive on this one. Just try it for a second, see if y'all can work that out. And I know some of you will use algebra, right? So you might say X is or equals 125% of Y. So 1.25 times Y. And you'll solve that equation. But even when you do that, I thought what was interesting about this is the form of the answer is not what we had hoped for, right? We solve for Y and we get that, and that doesn't really look like any of those. Divided by 1.25, oh man, so you could do some more algebra. X equals, 1.25 is 5/4. And so that's really 4/5 times X equals Y. So 4/5, which is 0.8. Eventually get the answer using algebra, or using your calculator at that point. But I think there's other ways of doing this. Again, I think the algebra, Tom, you've been working with students the last couple of weeks, I know, at least once a week.
Mhm.
Do they always, first of all, do you think they could all handle that algebra? And do they always think of algebra? What's your experience working with students? Just,
Some of them, they see percent and they go on to the next problem, unfortunately. But what we try to do, as you know, that going from words to symbols is a big deal on the SAT. Being able
Yeah.
to say X equals 1.25 times Y is a huge thing. So I'm really trying to get them to do that, but I'm not sure how many will. And then dividing by 1.25 is kind of a mess for them. I
Yeah.
will point out that Nicole Ayers had I thought a pretty good one. She went right to fractions and said X equals 5/4 Y, knowing that that was 1 1/4. So
Yeah.
Y equals 4/5 X. I mean, she saw that reciprocal thing going right away. And then of course
Right.
she has to know that 4/5 is 0.8. But um, I thought that was a nice strategy going to simpler fractions. But you're right, the students really do not like this and have a hard time with it, especially because of
Yeah.
the answers.
So this is a calculator problem. And I think one of the strategies, again, here is substitute numbers that are easy. And Tom, I don't know if you do this, but I always, when I'm doing percents, I always use 100 as one of my numbers typically, if I'm going to plug in a number. So like if X is 125% of Y, I said Y equals 100 because that was an easy number for me to work with. So X must equal, I guess what, 125? Does that sound right? Right, so then
Okay.
I'm going
Yeah.
to use
Mhm.
those two numbers in this calculation. So Y, or 100, equals what times 125, right? So then I can start testing out these answers and see which one actually works. And by the way, I know that number needs to be less than 1, so I think these two answers are gone. If you're just kind of like thinking about, and I think someone just said that on the chat, eliminate C and D. It can't be larger than 1 there. And then you could just test, and you can almost just kind of see it's got to be 0.8. It's definitely not 0.125. And of course, you can also use your calculator just to test out the answers there at that point. But I like using numbers like 100 when we're dealing with percents because it's really easy to calculate the percent of improvement or decay from the 100 starting point.
And so Andrew also said it was a good idea to plug in 100 for X in this case and look at percent as over 100. But I like the way, Jeff, that you think of substituting numbers and
Yeah.
nice numbers to make life easier, and then you were able to rule out two answers very quickly.
So the question is there, could we use the numeric solver once you get an equation set up? So like putting X in there, you certainly could if you needed to. I'm not sure if this one calls for that, but we could. Also, sometimes Is there a way to type in, Tom, is there a way to type in percent in your calculator? Sometimes students want to type in percent, they don't know how to convert it.
I was looking for that, and I don't think so. Maybe
So
on,
let's see, so
is it on Inspire? Is it on
125,
Inspire?
if I wanted to say 125 and percent, I'm guessing it'd be in the book. If you hit Control Catalog,
Okay,
there is probably a percent on there right there.
okay.
Or you could find it, I think it might be maybe over here in the, no, it's not over there. I thought it might be in one of these spots also. So in the Inspire, you can hit Control Doc and choose percent. On 84, does anyone know if that's possible?
I was thinking no, but I'd love it if somebody could find it.
So let's see.
I'm looking under the catalog, and there's no percent there.
Yeah, you're kind of looking up when you scroll up.
And there's no percent, right? And there's no percent either, Percent.
Yeah. So I
So,
don't think it's an 84 command, but there is one on Inspire if students need that. I sometimes use the word percent. The emphasis there is cent means 100, so per 100, so you divide by 100 to talk about that. But students need that little help. Let's talk about this problem. I thought this was a really interesting one. It's got a circle here, has a center at -2, 1. Line T is tangent to the circle at point 3, -3. Which of the following points also lie on line T? I want you to try that problem for a minute and see how you approach it. I thought it was really an interesting problem. So in the chat window, how did you all solve this one? How did you, oh, okay, so perpendicular slope. So I'm thinking you saw that that was 90 degrees. That's the part of the definition of a tangent line, I believe. So maybe you found the slope between those points. So 1 minus -3 over -2 minus 3. So that would be 4 over -5. So that's the regular slope. The perpendicular slope would be positive 5/4. Right then, in terms of vectors, that's something I wouldn't have thought of. So when you say trying each option, I wonder what you mean by that. So just estimate by graphing the points. That's not a bad plan. Certainly some of these points I think could go, like this one doesn't seem like the right quadrant there. It's going to be, this one, 2, 6 is way up here somewhere. Those two are probably out right away. Yeah, if you know the slope is 5/4, you could then use point slope for that line. For sure, you could do that, I think. But I like eliminating A and B. I think that's really good for our students to see. So the equation of a circle here, so that would be what? X minus H, so plus 2 squared, plus Y minus 1 squared equals the R value. I'm just going to do Pythagorean theorem. This would be a difference of 5 this way and 4 this way. So 25 plus 16, is that square root of 41, I think? Square root of 41, so this would be 41 would be our equation there. Let's talk about Nspire and graphing an equation of a circle. So you can actually graph the circle. We could do a couple things here. So I want to talk about Nspire. Nspire is so powerful here that you can do a couple things. One is you want to make sure your grid is on. If you've never turned on your grid in Nspire, go to menu, and I'll talk about 84 in just a minute. Actions. So this would be menu view. So our menu view grid, and then you would go to line grid there. And that gives you a grid, and you can actually draw a circle if you wanted to. So you can go to menu, geometry, shapes, and go to circle. Choose the point -2, 1. Choose the point 3. If you have your grid on, you should be able to pick 3, -3 right there. You can actually draw that actual figure here. You can draw anything in geometry you can do here. So points and lines, and draw a segment between these two for the radius. But the only thing about this doesn't give you the equation of the circle. So at this point, you might have to, you could also draw a tangent line, but it's a little hard to get it exactly on the spot right there. This would give you an idea. If you pull that out, it would be very close, but I don't have the exact slope there that I'm doing, but it would probably go through that point or very close to it, and you can estimate it from there. Tom, have you ever used the tangent on the 84 before?
Drawing a tangent line.
Yeah.
Yeah, usually in calculus, we draw a tangent line, to see, and then check the slope of it for the derivative. Now, in a circle, it's kind of tough. It's kind of tough because you can't draw a circle. You have to do it in two halves.
Right. So I'm going to just show you, if you haven't seen the new tangent line on the 84, I want you to see it. So on the 84, you can actually go to, I'm going to just solve this for y in my head here. So I think it'd be 1. Tom, I don't know if you ever do this, but sometimes I can say plus, I think this will work. I've done this before. Guessing it works on 84. If you hit second parentheses, you get a brackets, and you can type in -1, comma 1, and that's kind of like a plus or minus there. And then you have to second close parentheses. So that should take our equation I'm about to write and multiply it by 1 and -1, kind of like a plus or minus there. And I'm going to type in square root of, hopefully this works, 41 minus parentheses x plus 2 squared. And I'm going to graph that and see what that looks like. Oh, let's do a different window here. So zoom 6. Tom, what was that window that you really liked? You told me the other day that there was a window that was really good for the 84 that was squarish. And
Yeah, and it's also called double decimal. Yeah, so -13.2 to
did you
13.
go to zoom decimal first?
Well, you could do zoom decimal and then double everything.
Okay. So zoom decimal and then go to window, and I'm just going to double everything. So times 2. Is this what you do?
Actually, what I do is I type it in and then I store the window, save the window.
Oh, yeah.
So that would be a good idea once you're done to store the window.
Okay, so if we hit graph, oh, that's a much nicer window. I can see why you like that window.
Yeah.
So it's got,
once you go ahead and store, once you store that, so in case we need it again. So
okay, so tell me how do I store that?
So window over to memory.
Okay.
And then number two is zoom store. And then you can zoom recall it whenever you want.
All right. Okay, so now I've got that window stored. And so I think the way that, let's go back to the tangent command. So I'm gonna go to draw tangent. So second program is draw. and there's a tangent command here. And if you don't know how to use a tangent command, you can always hit the plus sign. It tells you some stuff. It says expression, comma, a value. Okay, so here we're going to try this. So I'm going to hit escape here. So I'm going to choose the tangent command. I like when you go in the menu. I don't know if you've seen this soft key at the right here at the top. It says menu in the bottom right of the screen. I'm gonna hit the graph key, and I like going down here and changing the tangent to Y2 there. That way it'll automatically populate in my, as a function, basically. And so the tangent command, you can hit enter here. Oh, I didn't want that.
You weren't, yeah,
I
you
think,
weren't,
I think I was supposed to type the number first, wasn't I?
yeah, the ordered pair.
Okay, let me go back to graph. Let me go to,
You might want clear draw, maybe clear draw.
okay, there we go. Clear draw is number one. Thank you. Clear
Ooh.
draw.
Oh, because it was in y equals, so you have to clear out y equals. That's why. Yeah,
Okay.
you put it
It
in
did
y.
clear out the drawing. I forgot I made it not a
Yeah.
drawing. Okay. Second draw. So tangent is number 5.
And now you need,
Menu.
well, you need to type in the point, don't you?
Do I do that on, can I just type in, what's the order pair? 3? Can I press 3 and press enter?
3, -3.
Yeah. So I think if I press 3, it'll jump to that nearest point there.
Okay, okay.
And so now I've got I've got the equation now as my y sub 2, right? So I can trace this equation. If I mouse up, I'll be on that equation. I can type in 7 and see if I go to 2. I do. And so that 7, 2 looks to be the right answer. If I go to 8, I think it'd be a little higher than that. Looks like 3.25. So it does do some of those things there, which is kind of neat. If you've never seen that new trace feature, for sure there. Let's go back to this. If you haven't seen the relation command, this is another way you could type in this circle, is to use relation. So if you delete it on Nspire and hit relation, and then you can graph, you can type it just like that and type it in x plus 2 squared plus y minus 1 squared equals 41. And it'll graph that as an equation, which is different than drawing it in the circle there. So we can actually graph it like an equation. Tom, I learned this the other day, and I thought it was really interesting. I don't know if you knew you could do this, but you could actually do this. So on Nspire, let's say that you have an older version of Spire that doesn't have the relation command. I run into that sometimes, or for whatever reason, you don't have access to your relation command. If you go to a graph screen, you can actually do the nsolve command inside of the graph there and graph. I don't know if you knew you could do this. So if you go to, I'm just going to type nsolve. So nsolve x plus 2 squared. Whoops. So x plus 2, I believe this will work, squared, plus y minus 1 quantity squared. Whoops. Y minus 1 quantity squared. Equals 41, comma y. So if I solve it for y, it graphs, well, it graphs at least half the circle, the half I needed, actually. So I would have to, that's interesting. It only graphed half of it because I didn't put the plus or minus in there. But isn't that interesting that it's solved, that it'll graph something that
Yeah.
it doesn't even show the equation for in the CX? I thought that was fascinating. I didn't know that.
No, I didn't either.
Yeah.
Now, one of the things, you showed a lot of stuff here, and you're trying to illustrate how to use the calculator, which is really kind of cool. Especially, I like the idea how you use the list so that you could do two things on the 84, the plus and the minus with the one and the negative one. Really thought that was kind of cool. But I have to give a shout out to Paul. Paul had a really good answer.
Yeah,
He said, go to the like the 0.3 -3, and we
yeah,
found the slope to be 5/4.
yeah.
Add 5 to the x, add 4 to the y, and you're at 7,2
Add 5 to this, add 4 to this. Oh, wow. Isn't this beautiful?
because of the slope, you know. And then other people were talking about the point slope form and showing and they ruled out A and B right away, as you did.
Yeah,
C and D were the only possibilities. And if you just substitute into the point slope form 7,2 or 8,1 works out. In fact, 8,1 gives you a fraction right away. So that kind of rules itself out because of the
yeah,
5/4. So we've got some really good ideas from other
yeah.
people too. Though
That's
I
really
get what
cool.
Jeff's doing. He's trying to illustrate cool things on the calculator that may not apply to this problem best, but they're really just cool things to know about.
Yeah. Okay, let's try number 10 here. And this one, I just wanted to, first of all, I don't know, I didn't pay attention at first, but the more I looked at this graph, I don't like this graph very much. Do you see this little thing right here?
Yeah.
Like, it's very confusing, I think, when you have a graph that is not, like I would never draw a graph like that. You know what I'm saying? Where you can't actually see like where it would hit the y-axis. I think it's just confusing. Do you like that kind of graph or no, Tom?
Well, I never graph it, but I've seen them in books just because they're trying to save space.
Yeah,
Um, and I get it for like maybe a histogram or something like that, you know, but for one that should show slope and y-intercept, it's not the best.
right. So I think this problem is kind of interesting in that they selected a certain window. Really, they're looking at, it looks like, first of all, the slope is positive. So I thought right away, these two guys are out. So I really thought the window here they're really looking at is from 60 to 100. But it's deceptive as to where exactly it's going to cross the y-axis. So one thing you could do is adjust the window in your calculator. I mean, this is probably, let me go with the 84 here. So this is probably something you've been able to do, but I mean, still like with students. So if you go to, like if I go and just graph this guy here, I want to be able to adjust my window appropriately. So 340 plus 5.5. And we're gonna, I guess I'll just start with the zoom 6 here. And if you go to window, you can't see anything really, right? So we want really only from 60 to 100. So I want my X minimum to be 60. I want Y max, X max to be 100. And this is a little nuance that you may not have known about the zoom 6 command or zoom fit, Tom, but the zoom fit command only adjusts Y values. So if I go to zoom fit at this point, and zoom fit, you almost have to scroll up to find it. It's right there at 0 or scroll way down to find it. But if I go to zoom fit there, it only adjusts the Y values. So now I see only the Y values. I should be able to trace on here. And can I see some values? I can see that it's 60, and you can type in 60, I believe, because it's one of the things. It has, it looks like it goes to 670 there. So you can see over here, we see that that's right around 670, right about there. That seems about right. So B is definitely the answer. But that's just a different way of kind of looking at the window. Is getting the do you ever use that zoom fit to just adjust the Y values, but the X values stay what you have them at?
I don't use it very often. I usually just play around, but that is a good idea.
Yeah. Because that way I didn't have to adjust it for each problem. I could just look at this particular problem and automatically adjust it and kind of does that. But you have to set your X values. The zoom fit only adjusts Y values. I think that's a really neat feature of the zoom fit command there. Let's talk about this one. And Tom, you had the same, I know when you saw this problem, you had the same idea I had. What was your idea that you would use? You could talk about this problem.
Yeah. I thought to use a slider for B and just graph x squared plus 8x plus B, and then let the slider be 8 and 16 and see what happens, whether it's at 8, it's at 16, greater than 16, less than 16. I could actually see it graphically, even though I could do this algebraically.
Yeah. So so with this one, with Nspire, if you put a variable in there, then it will automatically say, do you want to create a slider? And I'll say, sure, okay. And now it's got a slider here. You can move it around if you want to by grabbing it. If you right click on it, on the calculator, a right click is control menu. So if you right click on it, you should be able to adjust the settings so that the maximum value, I need it to be at least 16. I'm going to make it 20 maybe and say, okay. And so now when I grab this slider and move it, it should, you could see when it goes to 16, it's right there at one solution exactly. But if I go more than 16, it doesn't have any solutions, but it seems like everything less than 16, it's got 2 solutions there from the intercepts. So it's really interesting. You can just make your own slider to do that. On 84, Tom, is there a way on 84 to do this as well?
The slider?
Well, not a slider, but what could you use on 84?
Oh, I mean the transformation app.
Sure. You go apps, transformation. If you scroll up, you'll see that one. And wow, that was weird.
Yeah, it is weird.
This would only happen on a webinar, I think.
Sure.
I'm going to close that down.
So while Jeff's doing that, what he's going to do is run a transformation app, and then in Y1 he'll graph x squared plus 8x plus b, and then b will now become like a slider. So he'll be able to either type in values for b or increase or decrease values for b as well. I think it's under TI Smart View.
Yeah, oh, here it is.
Emulator software, there it is.
There we go.
Okay. Yeah, that probably happens about once a year and just happened to have on a webinar.
But it's a nice visual because you don't think about, I guess, how that would affect the graph, changing the value of B there. Okay, so if we go to apps, transformation, and start it, what's nice about this is I think A, B, and C all work here for variables. I think those are the only variables that work. So if you type in X,
A, B, C, D, 4, there's 4.
Okay, plus 8X plus B, if I hit alpha B to type in a B, now when I graph this, so it automatically puts the variable B there on the screen. If I go to the right, I go up by ones, and you can see right when I get to 16, it has 1 solution, and 17, it doesn't have any solutions here. So it just has a really nice, clean look to it. It's kind of a great way, using that transformation app can be really nice for using for accessing sorry. There we go.
And also,
Brackets,
if you're
uh,
if yeah, and if
yeah,
you're in a hurry, you can just type in the number you want. So if you want to type in 8 or 16, you
sure.
don't have to keep clicking. You
Yeah.
can actually just go right to it.
And after taking a lot of these tests, I'm sure, did anyone talk about the discriminant, using the discriminant here?
Yes, that did pop up. That was a biggie.
Yeah, I mean, that would be a really nice way to do this problem. So you'd have 64 minus 4 times 1 times b. And we want this number to be, let's see, we want more than one solution or exactly two, so greater than 0. So what value for b would make that greater than 0? And so then you can think that through and solve that problem to solve it. So subtract 64, divide by -4, and you've got, you know, be less than 16 there. I thought it was a really interesting problem to have there. And without a calculator, it's, again, if you know your math, your discriminant, it's great. But just having the access to be able to graph it and check some of those numbers. So Tom, like you're saying, you could just choose some values like what happens if it's 16? What happens if it's 17? What happens if it's 15? So, or 8 there, just to see what would happen with some of those. Any other comments to talk about, Tom?
Not really. Substituting values. Some people say
Yeah.
they never use the app. So cool. They love the app.
Yeah. The newer app is really a lot cleaner than the older one. I really kind of like it on the 84.
Yeah.
And it just automatically works, which I love. I mean, it wasn't a big setup there. This one was, oh, Tom, I don't know. I mean, this is a monster algebra hard problem, isn't it? Did you
Yeah,
feel like
I was surprised that was not so nice.
it was not so nice? And it's not even a multiple choice, right? So we don't even have, we can't plug in answers here. I mean, this is a monster here. So, and that's what this test is. The SAT is an algebra test at heart. And if you're not really strong in algebra, oh man, some of these problems are going to be tough. So this one says A and B are greater than 0. And 9 times, let's see, 9 times the square root of A is equal to, so 16 times the cube root of B. So Tom, kind of like you're saying, we're kind of writing a math equation from the words, and then it goes one step further. So 9 times the square root of 3/4 equals 16 times the cube root of B. So we've got to not only just solve for B, but also then for what value of X is A to the X equal to B? A to the X, so 3/4 to some power equal to B. I mean, this was, I mean, really quite an interesting problem, I thought.
Yeah, and the answer wasn't even a nice number.
Yeah,
That was the other
it
thing that got
wasn't
me.
that
It
nice.
wasn't like
You know,
even a nice answer.
Tom, I don't know if you tried this. I tried to algebraically do it just to see what would happen here. Like to see if there's a way to actually solve it and actually get it just really nice without using the calculator here. And it does kind of work out here. So
Oh,
if
it
you
does.
put both,
Yeah, it does.
if you put both sides to the third power, you really have to be intentional about it though. So I rewrote this a little bit differently. So I wrote it, this is what I did. So I wrote 3 squared here times, instead of square root of 3, I wrote 3 to the 1/2, if that makes sense. Instead of 16, I wrote 4 squared. And then in the denominator, I wrote 4 to the 1/2. I know I did a lot of steps there, but you might have followed that. And then I said, okay, so let's simplify inside of here. So in the inside of here, this is 3 to the 2.5 or 5/2. That's a 5 there, 5/2 to the third. and that's 4 to the 5 halves. And then that is equal to 3 to the 15 halves over 4 to the 15 halves, which kind of answers the question, A, which is 3/4, has to be put to what power? The 15 halves power, which is actually the answer, or 7.5. But wow, look at the algebra of that. Like, how many students are going to do all of that algebra there? How long did it take to finish that?
Yeah. And you went to fractional exponents. I stayed with radicals until for the whole thing.
Oh, you went with
And
radicals the whole way.
the whole
Yeah.
way, yeah. And it ended up again, I got 3 to the 7.5 over 4 to the 7.5.
Yeah.
Yeah, it
But
was not.
so how can we do this? Does anyone have any ideas? How could we do this? You know, you kind of get to this step here, where let me just back up to where we were here. So we're kind of there. How would you do this? So someone said, so numeric solver. So we could use the solver. So the 84 has a solver on there. So if you go to the math key and go up one click, there's a solver. So it's really kind of a nicer solver than it used to be. So I feel like, so if you type in 9 times the square root of 3/4, so alpha x is a fraction there, so 3/4. And then the right-hand side there is 16 times the cube root. If you hit the math key, I think there's the cube root of, I'm going to put x here instead of b and say okay, and then say solve. And it tells me that x is 0.1156. So we know what b is. B is 0.1156 something. So, but boy, I have to think about this. So a, which is 3/4, so 3/4 to that power. So Tom, is this right? Since this is stored for, is this stored for x right now?
Um, I I
Let's see.
think, yeah, I think so. Yeah, I think it is. Just type
If I
X.
type x, it thinks it's that number. Oh, that's nice,
Yeah.
right? So if I put 3/4, so I'm going to put that parentheses just to be safe here. So 3/4 to the power of, whoops, sorry, I did not mean to type a 9 there. To the power of x, which is, again, that number. Wait, now I'm confused. What did I do wrong? A. Oh, is B. Sorry. A to what power is B?
Yeah.
Oh my goodness. Okay. So now, okay, so I'm going to store B. So I'm going to take this number and store it as B. Boy, this gets confusing. I'm thoroughly confused by this problem, trying to do it, doing this method. Okay, so if you go to the math solver again, now we have B stored. So we're going to go math solver, and we're going to say a to the x. So a, which is 3/4, to the power of x. And this we want to be b. And we're going to solve that. And the answer is 0.75. Wait, is that right?
You have X equals 1 there.
Oh, x, I should solve for that. So, oh, I have to hit alpha solve. Alpha
But now your B
solve.
value changed though. Is your B 0.75?
No, it should have been stored.
Yeah. Yeah, I think you got the right idea, but I think this is a long, long way around.
It is a long way around. Does anyone have any other ideas than the solver there?
David Young had the suggestion, why not take the 6th power both sides earlier on? And other people are asking, how long did this take? Also solving with logarithms, using logarithms, either logs or natural logs.
Ooh, that's an idea. Interesting idea. So I think that
Yeah,
you can do, yeah.
Yeah, there's a lot of, I mean, too many for me to bring up, but there are a
What
lot
was
of
the answer?
different
Was it
ideas here.
7.5 or 15 halves? Yeah.
Yeah, the correct answer is 15 half, 7.5.
Yeah.
So where are, oh, we're almost out of time here.
Oh, we are. I'm sorry. Sorry. I got into the weeds a little bit on a few of these. But I hope you saw a few new ways to use your calculator to approach problems, and you see just how tough some of these algebra. Yes, very similar. It is almost identical to an actual SAT problem. That's a good question from the calculator section. Tom, can you tell us about activity you've done that is seasonal for this time of year?
Oh yeah, if I could share my
Okay.
screen, I'll show that. But first of all, Jeff, thank you for all that stuff. That was really good. Um, I learned a lot. And so, all right, so are you able to see my screen?
Yeah.
Jeff, okay, all right. So one of the things I do every year is do some Super Bowl math activities, and I have them for both the 84 and the Inspire. So this is the link to it, bit.ly/Super Bowl 57 math. And there are 3 links there. One has Super Bowl fun facts and interesting stories. One has, and then there are 2 activities on the 84 and the same 2 on Inspire. Let me just show real quickly those there. So this is the fun facts, shows the Super Bowl price for the tickets. Also, it has like how much does a 30-second commercial cost this year? It's between $6 and $7 million. 1970, it was $42,000. How did the name Super Bowl originate? Some fun facts, which teams have been there. My Cleveland Browns are the only team that have never hosted nor ever been in the Super Bowl of all the teams in the entire NFL. So, but the activities, hopefully you'll find interesting. One of is on the last digit scores for each quarter. So any of you do the pools, it'll tell you what's the most popular numbers and what are the least popular numbers. And I have some activities about those. I also have, and then you have all the programs and everything that go with it, the teacher notes, the student activity, and so on for both Inspire and for the 84. And the other one are the Super Bowl actual scores. What's the largest winning score, smallest winning score, and so on. And you can do that on both the 84 and the Inspire. So if you're interested in those things, there's your link to it. I think that Mike is going to put in a link to where we can get the PDF of the SAT problems that Jeff did tonight. Thank you for letting me chime in on that. So I'll turn this back over to Mike.
Thanks so much, Jeff and Tom. In the chat window are the links for the certificate and the documents that we've been promising all night. In case they're not working for any reason, just hang tight. You'll automatically get a follow-up email, and in that follow-up email will be links to the recording, the documents, and the certificate as well. We did promise that tonight we're giving away to one lucky winner a TI graphing calculator, and tonight's lucky winner is Mike Tucker. So, Mike, congratulations. We're excited to have you think about which graphing calculator you want. So start thinking about that. We'll reach out to you, Mike, in a couple of days over email to get that information from you. Again, to receive your certificate, go ahead and click the link in the chat. And if you're watching this on demand, copy that link into your favorite browser to receive your certificate. One of my favorite things about tonight is I sort of imagined whenever Jeff and Tom were putting this all together that we were just going to start one by one, just doing all these calculator problems from the SAT, like here's number one, here's number two. And we didn't do that. And I thought, like Tom said earlier, we really saw some interesting ways of tackling some of these questions, but also just kind of good calculator use and technique. So I hope everyone was able to get something out of it tonight, and just a huge thanks to Jeff and Tom for all the time they put into putting this together tonight. And thanks to everyone for joining us.
Thanks, guys.
Good night.
And we hope to see you back online next week. Tom, thanks again for sharing all those extra activities for the Super Bowl. Hopefully those will be used as well.
Hope so.
Thanks, everyone. Have a great week. See you next Tuesday.